Okay, we've got a circle that they've called S, unusually for a circle, because they want to use the letter C to mean the center of the circle, and it touches the x-axis, okay, and we have to write down an equation for S. So to get an equation for a circle, okay, starting point for a circle is two things. We need a center and we need a radius. So get those two things set up. Well, the center's not hard because you're given that. The radius, well, okay, they don't tell you that specifically. They do tell us it touches the x-axis. We can see it touches the x-axis here. So maybe this point's important. Maybe we can see from the diagram what this distance here will be, and that will be the radius. So if I've got a center and a radius, then I could just fill in the slots for A, B, and R in this equation. Aren't they kind, giving you the standard format of the equation in the question? Then it tells us that the point P lies on the circle. Okay, so this is re-entry point. Even if you've got the wrong circle, you can still work with this point P that they give you. So we've got to find the gradient of a straight line passing through the point P and C. So how do we find gradients? Well, there are several methods for finding a gradient in Core 1, but we want one that comes from 2 points, because I've got point P, there it is, I've got point C, so this is the 2-point method for gradient. So it's something minus something over something else minus something else, and you simplify your answer, but it's just one easy mark. Hence, that means we're going to be using that. Find an equation of the tangent. Well, a tangent is a straight line, so for any straight line we need the standard two things for a straight line. We need a point and we need a gradient. Okay, so think about the point. Okay, it is the tangent to the circle at the point P. So the tangent has got to go through this point P. Okay, and then I need a gradient. Okay, well, I've worked out the gradient of PC here. Now this is where actually marking your point P, okay, it's the 0.31, so maybe that's somewhere like this, maybe this is P. Here's the gradient that I found in part B1, which I know I need to use somehow, but the tangent is like this dotted line here. So having worked out this gradient, you need to think about what you need to do to it to get the gradient of the dotted line. So once you have a point and a gradient, then it's the y minus y1 recipe. Okay, but this time we do have to rearrange that into this form. A, B, and C are integers, so integers means whole numbers. So when you get y minus y1, you're going to get a fraction times another bracket with the x minus whatever x1 is. Okay, the way to deal with this fraction is to multiply both sides by the bottom of that fraction before you do anything else. You should have examples of that in your notes, and you should have done this 1,000 times by now. Then in part B, dotty 3, we've got the point Q also lies on the circle S, and the length of PQ is 10. So I don't know where to put Q on my diagram, but I should do it on my diagram. Maybe a clean copy of the diagram will help. So I've got P here, okay. I've got Q somewhere else on the circle, okay. Alright, and I want the shortest distance from C, the center of the circle, to the chord PQ. So I don't know where Q will be. So I can put Q wherever I like, draw on PQ, and then we need to find the shortest distance from C to the chord PQ. So that will be this distance here, okay. And I know the overall distance of PQ is 10, so I could maybe work out what these are, okay. I want to work out what this distance is. I'm going to call that D. That's what I'm trying to find. Well, I know what that question mark is, and often in a diagram, joining stuff to the center is a good plan. So if I need to make this diagram look more helpful, maybe if I take point C and join it to the center, do I know how long that is? Yes, I do, because that's a particular measurement of the circle. So now I've got this triangle where I know that one, and I know that one, okay. And I want to work out this D from this one that I know and this one that I know, and I might want to think about if this really is the shortest distance, about what that angle is. Okay, so hopefully you will now see what you need to do in that right-angled triangle to find the missing distance D. Okay, hope that diagram's clear enough to you on the video. Can I be bothered to redo it? No, I can't. I hope that's clear enough.